This lesson will give some more examples of solving radical equations. So, in particular, the more complicated examples are when you have two roots and you have something else as well. So if there's just two roots, then you can separate them and get them both each to one side and square both sides. That's nice and easy. But when you have three terms, two of them are roots, there's a bit more complicated of a process. So essentially, you're going to need to repeat the process twice to get rid of all your roots and find x. So if you have two roots, you want to isolate one of them, get one of them alone, and it doesn't matter in this case which one. In general, it's best to get the more complicated one on its own first so that it gets squared away first. In this case, they're pretty equivalent, so let's just keep this one here and add root x minus 1 to both sides. So that gives us square root x plus 1 equals 2 plus square root x minus 1. Now we can, because we have a root by itself, we can now square both sides, and this square root is cancelled, but this here is going to follow our perfect square trinomial formula. So by now you should be familiar with the fact that rather than multiplying this out completely or making the mistake of squaring both of these, you want to take the square of the first plus, in this case, twice the first times the last, which is the middle term, plus the last squared. So now we have x plus 1 equals 4 plus 4 root x minus 1 plus, and now this square cancels that, we have x minus 1. Now we want to simplify everything as much as possible, and now we're returning to this step again, the squaring step, so that we can get our root by itself again. So first of all, if we subtract x from both sides, that'll be gone. The 4 minus the 1 is a 3. And so when we move it over to the other side, we're going to need to subtract 3 from both sides. So if we subtract 3 from both sides, and that gets rid of the 4 and the negative 1, which is the 3, that's negative 2 equals 4 root x minus 1. And at this stage, you can already square both sides. However, you want to pay attention to something here. The fact that we have a negative equal to a positive times a root, and we know that a root is always positive, there seems to be something wrong here already. So you can pull it through if you don't notice it, but remember, you always want to check your answer in these because of this exact issue. So we could square both sides, and we'll get 4 equals 16 times x minus 1. We solve it, we get 16x minus 16 equals 4. And you can finish that off, add 16 to both sides, and you get 20 equals 16x. So x is 20 over 16, which simplifies to 10 over 8, or 5 over 4. So now we want to check. So 5 over 4 plus 1, which is 4 over 4, and see if that minus 5 over 4 minus 4 over 4, which is 1, equals 2. So this here is 9 over 4, and this here is 1 over 4. So that's 3/4 minus, 3 halves minus 1/2. Is that equal to 2? No, that's equal to 2 over 2, which is 1. So there's a problem. So this one actually has no solution because the only solution that was possible based on our algebraic procedure did not work. So let's take a look at this other one. Notice that you should know that if you have exponents that are fractions, that those become roots. So this is the same as root 3x plus 4 minus root 2x minus 4 equals 2. And again, we want to get one root alone so that we can square it away. So we're going to add this to both sides. And then now we can do our squaring step. Squaring complete sides, not each term. Remember, you can't square each term. If you had 1 plus 3 is 4, you can't say that 1 plus 9 is 16. So square this, you get 3x plus 4. And now when you multiply this out, you'll get 2 squared plus twice the first times the last plus the last one squared. And that leaves you with 3x plus 4 equals 4 plus 4 root 2x minus 4 plus 2x minus 4. And now let's put everything together. So in this case, so we have the 4, there's the same number of 4s. Okay, so this is 4 minus 4 is gone. And we can minus the 2x to both sides. And so that's 3 minus 2 is 1x plus 4 is equal to 4 root 2x minus 4. And so now we can square both sides, or we can divide by 4. It's probably easier to square both sides at this point. So that leaves us with x squared plus 2 times 4 times x plus 16. See, because this one is now being expanded completely, but this here becomes 16 times the bracket 2x minus 4 when squaring both of those terms. So this one's a little longer, so we gotta pull through it. Let's continue over here. So we have x squared plus 8x plus 16 equals 16 times 2, which is 32x, minus 16 times 4, which is 64. And now, because we have a square, you need to remember that because we have this square, we need to we can't solve just for x without bringing everything to one side equal to 0 and factoring. So we're using a whole bunch of learning objectives here to solve this one problem. So it's all coming together, hopefully. So let's bring everything to one side, subtract the 32x, and remember the reason for this was so that we can get it equal to 0. So this will be x squared, and then 8 minus 32, which is negative 24x, and then 64 plus 16, which is 80, equal to 0, because these went away. So now we have this equation to look at to find some potential answers. And in order to solve this, we need to factor it. So we need to look for factors. Because our coefficient is 1, we're going to find two numbers that multiply to 80 and have a sum of 24. So go through your options. 1 times 80, 2 times 40, 3 times doesn't work, 4 times 20. Oh, 4 and 20 add to 24. So 4 and 20, both negative, will work. So that actually gives us x being 4 or 20. So now we can't just stop there, we need to still check. So we need to check which of these works. Do both of them work? Do neither of them work? So you want to plug it in to the original equation and see. I'll do this in green so that you can see it in a different color here. So 3 times 4 plus 4 minus 2 times 4 minus 4. And is that equal to 2 is the question. So that's 12 plus 4, which is 16, root 16, minus 8 minus 4, which is root 4. So that's 4 minus 2, and that's equal to 2. So 4 works. Let's try 20. So 3 times 20 plus 4 minus 2 times 20 minus 4. And check that out. So 3 times 20, that's 64. And then 2 times 20 is 40, minus 4 is 36. These are nice perfect squares, aren't they? So see if that 8 minus 6, yes it is 2. So in this example, both 4 and 20 are solutions. Finally, you might get some examples where they're not so complicated, but there are more letters going on in the problem. So say you have a formula and somebody wants it solved for L and they don't really know how to do math. So the question is, can you solve it for them so they can just plug in the formula, say, into a computer rather than computing it themselves? So maybe your friend needs your help. So you want to solve it for L. So we need to somehow get L by itself. Well, first of all, it's under a root. So we kind of need to square both sides. We're allowed to do that. Now notice you could divide by the 2 pi first if you'd like. That would be t over 2 pi. You don't have to, you can do it later. But try it both ways, see what works best for you. Square both sides, t squared over 4 pi squared equals L over 32. And now we can multiply by 32, and we get L equals 32 t squared over 4 pi squared. And you can simplify the 32 over 4, and that gives you 8. So L is equal to 8t squared over pi squared. And what if the variable's in the denominator? Well, similarly, let's get rid of what we have here. Or you could square both sides right away in this case, because this is just multiplied. So that'll be n squared. I'll do it this way this time so you see the difference. So you'll be just squaring both of these. So you'll have 1 over 4 pi squared times a over r. So we need to get rid of this 4 pi squared. And we could have done this here at the beginning and multiplied both sides by 2 pi. Whereas in this case, we're going to multiply both sides by 4 pi squared. So we'll have 4 pi squared n squared equals a over r, but we want r by itself. So there's a couple things we can do. We know that if we have a rate proportion like this with 2 fractions, we can actually flip them. So you can see this as 1 over 4 pi squared n squared equals r over a. However, if you're not comfortable with that, you could just use algebra and say multiply by r on both sides. And let's get rid of this because you'll see that later. So that would be 4 pi squared n squared r equals a. But then you want r by itself, so you actually end up dividing by that other part. So it actually does flip over. Those are all factors. So you have r by itself.